This video, we're going to talk about the unit circle. The equation of the unit circle, well, it's centered at the origin and the radius is 1. So it's x squared plus y squared equal 1. Why is that a reasonable equation? Well, to get on the circle, you have to be 1 unit away from the origin. The origin is 0, 0. So let's use the distance formula. To be on the circle, x minus 0 squared plus y minus 0 squared, that should equal to 1 squared. The distance squared, which is 1. In this case, the distance has a special name. It's the radius, or r. So you have x minus 0 being x, y minus 0 being y, and this is equal to 1 squared, or 1. That is the equation of a unit circle. Unit meaning the radius is 1. So we want to decide whether or not certain points are on the unit circle. So how about you want to verify that the point 3, 5, 4, 5 is on the unit circle. That is, it's on that circle. Well, it clearly says if you square the x value and you square the y value, you're supposed to get 1. Well, let's see if that is in fact true. 3 squared over 5 squared plus 4 squared over 5 squared. Does that equal 1? They have the same denominators, so I just add the numerators. And yes, 25 over 25 is 1. So it is on the unit circle. How about same problem with this point? 5 over 13 minus 12 over 13. Is that point on the unit circle? So you square the x value, you square the y value, and you decide whether or not it's 1. 5 squared is 25, 13 squared is 169. Negative 12 squared is 144, 13 squared is still 169. Does that equal 1? Well, in addition, the denominators are the same, so keep them the same and add the numerators. Get 169 over 169. And yes, that's 1. Now, there, in addition to the units of degrees for an angle, there are another unit of measurements. They're called radians. You can have pi radians. You can have 7 radians. You can have 2 radians. You can have pi over 3 radians. Couple of comments. If you are going to write radians, a shorthand way is to just say rad, 2 rads, pi over 3 rads. But more commonly, if we're talking about an angle and it's in radians, you don't have to say the radians. So if we know that we're talking about an angle and we say 7, that means 7 radians. If we say 7 degrees, that means it's 7 degrees. We can say pi degrees, we can say 2 degrees, we can say pi over 3 degrees. For example, this will be approximately 3.1415 degrees. Because pi is approximately 3.1415. Just like when it comes to feet and inches, there's a relationship. 12 inches equal a foot. Well, we have the relationship that pi radians is 100 degrees. So when somebody says pi equals 100 degrees, well, clearly the right side is talking about angles, the measure of an angle. So is the left. That is, that pi is understood to be pi radians. So if you were asked to sketch on the unit circle, sketch pi over 4. Now, if these two quantities are equal, that means pi over 180 degrees is equal to 180 degrees over pi equal 1. If the top and the bottom are equal, you get 1. 12 inches divided by 1 foot is equal to 1. If you don't believe that, nobody will disagree that 12 inches is a foot, and when you divide by a foot, you get 1. If the top and the bottom are the same and they're not 0, the division is 1. So if I take pi over 4 and I multiply by 1, I want to convert it to degrees because we are more familiar with degrees. So I'm going to put the degrees on the top and the pi radians on the bottom. This will cancel out, and 180 over 4 is 45 degrees. So off the positive x-axis, we know that if we go up to here, it's 90 degrees. So 45 is halfway. That angle is 45, is pi over 4 radians. How about you're asked to sketch 7 pi over 4? Now, there's a couple of ways of doing this. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. Here it is, 7 pi over 4. It is that angle. Okay, a bit cleaner looking. It is this angle here. That is 7 pi over 4. Now, like I said, there's two ways of doing this. If you have 2 pi, which is 8 pi over 4, and you take away 7 pi over 4, you get, so something's bothering me. I don't know what. If you have this angle and you take away 2 pi, you get back to the same place. So it's negative pi over 4. Unit circle. Negative pi over 4, that just means I go backwards. I go back pi over 4. So there's my angle. That's another way of doing it. How about t is equal to negative pi over 3? Well, you can just replace pi with 180, and you get negative 60 degrees, or you can multiply by 180 over pi. The pi's cancel out. 3 goes into 180 60 times. You get negative 60 degrees. So I got the same answer. And negative 60 degrees, well, so we're going negative, that means we're going in that direction. So we go all the way out to there, that's negative 90. So we go a third of the way. That angle right there is negative pi over 3. Okay, this angle right here. We just go in the opposite direction. What if you were asked to sketch this angle? Since it doesn't say degrees, it must be in radians. And remember that pi is 3.14. Oops. So half of pi would be 1.57. This is a little bit more than pi over 2. It's a little bit more than pi over 2. Okay? And pi over 2, remember that pi is exactly 180 degrees over 2, 90 degrees. That is 1.57 is about 90 degrees. So this is a little bit more than 90 degrees. So, positive x-axis, a little bit more than 90 degrees. That angle is about 1.7. What if you were asked to plot or to sketch 7? T equals 7. That means 7 radians. Well, remember, pi is about 3.14. So 2 pi is about 6.28. And half for pi is about 1.57. So 2.5 pi will be about 7.85. So it's a little bit less. What we want is a little bit less than 2.5 pi. Now, what you can also do is you can do 7 minus 6.28, which is 2 pi. In other words, we went 6.28, and then we have to go 0.72 more. Okay? Now, we know that pi over 2 is about 1.57. If I divide that by 2 again, I get 7.535. which is a little bit more than I want to go. I don't want to go pi over 4. Now remember, pi over 4 is 180 over 4, which is 45 degrees. I don't want to go quite 45 degrees because that's that number. Sorry. Just a little bit off. I apologize. 7.75. This is a little bit more than what we want to go. So here is pi over 4. I go a little bit less. There it is. Okay, that angle is about 7. Now, what it really is it went around once and then it came back there. Going around once was 2 pi, which is about 6.28, and then we went 0.72 more for a grand total of 7. And 0.7535 was pi over 4. I mean, just take 3.14 divided by 4, 28, 3 left over. Put some zeros down. 4 into 34 goes 8 times with 2 left over. Did I actually do that wrong? Oh well. It's 0.785. Not sure what happened. Okay. So again, we only needed to go 0.72 more, so we don't go 0.78. We go a little bit less. Suppose we wanted to sketch the point on the unit circle, 4/5, 3/5. Well, earlier we verified that that point is on the unit circle. Remember, this is 1. You know, you have 1/5, 2/5, 3/5, 4/5, 5/5, or 1. 1, 2, 3, 4, 5/5, or 1. So 4/5 is right there. So there it is, 4/5, 3/5. My scale's a little bit off, but when you look down, you see 4/5, and when you look across, you see 3/5. I mean, if I scaled it better, 3 would have been there. Okay? So let's actually do that. So that's going to be 3, 4, 5 at the top. 1, 2, 3. Okay, that would be this point right here in blue. That would be 4/5, 3/5. Okay. So this here is the point T. Okay, that's the point T. So we want to find pi minus T. Keep in mind that that's the same as negative T plus pi. Well, negative t would be right here. That is, instead of going positive t, we just go back the same amount. Right there is negative t, which happens to be 4/5, negative 3/5. And then I add pi. Well, if I'm here and I add pi, that is, I go halfway around. And right there is going to be negative t plus pi, or pi minus t. Okay. So just go halfway around. And this angle would just be negative t. What if we wanted to do pi plus t? Okay, pi plus t, which for the record, if it makes it easier, it's t plus pi. So, right here was t. So, you just go, you add pi, you go halfway around, and you get here. Okay, that point would be t plus pi. What if you wanted to do 2 pi plus t? Now, you have two ways of doing that. You start here always, and you go 2 pi, and then you go t, and you end up right there. Or you could first, you can think of this as t plus 2 pi. You can first go t radians, and then go around 2 pi. Either way, it brings you back to the same exact point. Now we're going to talk about reference angles. Reference angles are very important. Suppose, so this of course is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If an angle lands in quadrant 1, wherever it lands, you go to, from this point on the circle, to the x-axis. And that there is the reference angle. Let us keep drawing this. Suppose that you have an angle in quadrant 2. So you're in quadrant 2. The reference angle is wherever it terminates the angle, go down to the x-axis. That there is your reference angle. If you have an angle in quadrant 3, go to the x-axis, and there's your reference angle. If you have an angle in quadrant 4, well, the angle is that angle. Go to the x-axis. There is your reference angle. Okay. So the next set of exercises is going to be to find the reference angle. And I'll denote it like this. Find the reference angle of 5 pi over 4. Now remember, 5 pi over 4 is 1 1/4 pi. That is, it's pi plus 1/4 pi. Okay? So, I don't exactly go pi, I go 1/4 pi more. Well, this angle is going to be that 1/4 pi. And that problem is, what about 4 pi over 3? What is the reference angle of 4 pi over 3? Well, it's 4 pi over 3 times 180 over pi. Pi's are going to cancel. And 3 goes into 180 60 times. 4 times 60 is 240. So we want the reference angle of 240 degrees. Well, this is 180 and you go 60 more. That is, you end up here. That is your reference angle. It is 60 more. 180 divided by 3. That's the reference angle. So the reference angle of 240, or 4 pi over 3, is pi over 3. For the last problem, the reference angle of pi over 4, it is pi over 4. Suppose you want the reference angle of 11 pi over 4. What is the reference angle of 11 pi over 4? Well, remember, if you go 2 pi, you're back to where you started from. That is, you can take away 2 pi, which I'll write that way so the denominators are the same. So we get 3 pi over 4, the same as the reference of 3 pi over 4. Well, remember, that's 1 pi over 4, 2 pi over 4, 3 pi over 4. So that's our angle. And if I went out here, that's 4 pi over 4. From 3 pi over 4 to 4 pi over 4, that is, that angle is pi over 4. Always, always go to the x-axis. Suppose you want the reference angle of 2 pi divided by 3. So maybe it's friendlier to use degrees. You can always say that pi is 180 degrees. 3 into 180 goes 60 times. 2 times 60 is 120. Well, that's 90 plus 30 more is 120. So this must be 60. Because if that's 30, then this is 60. So the reference angle of 120 degrees is 60 degrees. But if they give you the angle in radians, you should give it back in radians. 180 divided by 3 is 60. Okay. Now, you should know how to divide 180 by various numbers. 180 over 2, that is pi over 2, that's 90 degrees. Pi over 3, that is 180 divided by 3, that's 60 degrees. Pi over 4, that is 180 divided by 4, this is 45 degrees. This one isn't very common, but 180 divided by 5 is 36 degrees. 180 divided by 6 is 30 degrees. And we generally don't do 7 and 8. 9's not very popular, but 180 divided by 9, that's an easy one. It's 20. So I would know all of these, and you don't really need to know this one and this one. Okay, definitely know the others. That is, know the ones in this blue box. Know how to divide 180 by 2, 3, 4, and 6. 2 goes into 18 9 times, add a 0. 3 goes into 18 6 times, add a 0. 6 goes into 18 3 times, add a 0. This one's a bit harder. How I do it is I divide by 2 twice. 180 divided by 4 is 180 divided by 2 times 2. Well, 2 goes into 18 9 times, so it goes into 180 90 times, and then 2 goes into 90, you should know, 45 times. That's how you get 45 degrees. Let us do one more problem. Suppose you wanted to find the reference angle of a negative angle. Well, let's convert it over here. Pi is 180 degrees over 3. 3 goes into 180 60 times, so we get 420 degrees. But you know what? That's the same as this number is 360 plus 60. It's just the same as 60. You end up in the same place. 360 plus 60. Or you go 60. You end up in the same place. But of course it's negative 60. It's the reference angle of negative 60 degrees. Okay? So let us draw that right here, and let us decide what the reference angle is. Negative 60 is this angle right here. Oh, that's right where the right angle goes. This reference angle is 60. Reference angles are never negative. So the reference angle of negative 7 pi over 3 is the same as 60 degrees. That completes this video on the unit circle.